Here we'll be talking about how to calculate the residue of this equation. Instead of from equation, we are going to calculate the residue. And here, the second question here, we are going to be looking at how to produce the volume of hydrogen chloride gas produced by 5.8 grams of sodium chloride. Now, this question circles around the stoichiometrics. No, when you look at every chemical equation, there is always a relationship that you can see there. There's always a relationship there that will help you to understand. That relationship that help you to understand this is it has to do with the stoichiometric relationship of the reaction. Now, here let's quickly rush through these questions. The first one said, like I said, I want to remind you that this question will be at the description of this video. And if you're joining us for the first time, we want you to subscribe and then like, share, let your friends know about us. So let's look at what we have here. The question says from this equation that is balanced, that should calculate what the mass of residue formed if 1.68 grams of sodium hydrogen triisocarbonate decomposed. This is the decomposition reaction of that sodium hydrogen triisocarbonate. Now let's look at what we have. From this chemical equation, we find out that okay, let's see from here. So if you look at this chemical equation now, you find out that 2 mole of this give us sodium triisocarbonate. 1 mole of sodium triisocarbonate, which is the residue, because these other ones they are going out as gas. This one is going out as gas. This other is going out. Water is going out as steam. This other one is going out as carbon 4 gas. So the remaining residue there is sodium triisocarbonate, which will not decompose. So 2 moles of this will give us that. So we are looking for the mass of this that will give us what will be the mass of the residue. Now, looking at this very well, you find out that the first thing you do here is to get the mass relationship, because this equation has to do now with mass and mass stoichiometric. So when we look at this, find out that from this balanced chemical equation, note something. We have from this balanced equation, it means that sodium here we have 23, sodium here we have 1 plus, and then this other one carbon we have what plus 12, and this other one oxygen, that means oxygen 3 times 16 will give us 46. Let me be sure. 48, sorry, not 46. 48, we have 48 here. That means 3 times 16, because this other one oxygen is 16. Now for sodium is okay. We will sum it up. Let's sum it up together. We'll get this thing together. It means that is what we have here. Sum everything, multiply by 2. That is the mass that is required. So let's quickly do that. Let's see what we're going to get. Plus 16, 1, and then times 2. So when we sum it up together, what we have here is 168 grams of sodium hydrogen triisocarbonate. That is what we have in this chemical equation. Now the reacting mass in this chemical equation, the composition of this, we have this 168 grams. Now for this other one, what we have here is sodium. Here we have sodium to be 26 times 2 plus carbon, which is 12, plus 16 times 3, that will give us 48. That will give us 48. Now what we mean, if we sum up the whole thing, if you sum these ones up, we have 106 grams of what? Of sodium triazocarbonate. That is what we have, of sodium triazocarbonate. So this is what we are looking at now. We have this mass to give us 106 of sodium triazocarbonate. So the next thing we are going to do now, we look at the mass given to us. We are given 1.68 grams. So what will this 1.68 grams be like? So what we're going to do here is, now we have 1.68 grams of sodium hydrogen triazocarbonate to give us 106 over 168 times 1.68. So when we divide this, what we're going to have there is, we have 1.06 grams of sodium triazocarbonate. That is the mass of sodium triazocarbonate that will be the residue. That is, if we are looking for since we are looking for the residue that will form when 1.68 grams of sodium hydrogen triazocarbonate reacts, will be this 1.06. All right, let's go ahead and see what we are going to do here. The second one says that sodium is a reaction between sodium chloride, that is sodium chloride, and tetrasulfur 6 to give us sodium tetrasulfur 6 and sodium hydrogen chloride gas. So let's look at how we're going to do this. From the chemical equation, the equation says this will be 6. That will give us that equation is not balanced. All right. So this is the chemical equation. So what we have here again, we're looking at sodium, the volume of hydrochloric acid that we produce. Now what we have here, if you look at it very, we find out that from this balanced chemical equation, it means that we're talking about what are we talking about? We're talking about the volume, and then we are given the mass of sodium chloride. Now from here we notice that sodium is what? Sodium in this is what, 23. This other one plus chlorine, which is all in brackets. So if we multiply through, what we have will be 8.5 grams. That is what we have. That means from this balanced chemical equation, this mass is what we have, the mass of the reactant. That's the mass of the sodium chloride that is reacting in this chemical equation, based on what we have here. So that's one other thing you should always note in every balanced chemical equation when you're dealing with any question that has to do with stoichiometry. Now this is what we have from this chemical equation. How do I get that? Adding up getting the molar mass of the sodium chloride, multiplying by the number of moles of the sodium chloride that is reacting according to the chemical equation. We're able to get this. So now let's look at this now. Here, okay, look at the next thing we're looking for, like the gas. Now we know we are given the molar volume of the gas, the molar volume, which is 22.4 gm3. So it means that for each 58 grams of sodium chloride, it will give us the same thing here. We have molar volume of every gas is what? 22 point. Okay, now we'll do it 22.4 gm3 inside. That is 22.4. Now, why am I doing this? Because in this reaction above, in the equation above, we notice that 2 moles multiply the molar mass of this. Then, since we are talking about volume, the 22.4 gm3 stand for what? That's volume, the molar volume. So 2 multiplying this, what we have here will look like this. We have a 8. This one will give us 4. This one will give us another 4. That's dm cube. Dm cube of what? Hydrogen chloride gas. This one is mass of sodium chloride. That will give us 44.8 gm cube of hydrogen chloride gas. So now, but in this reaction, we want to know what this one will give us. What are we likely, or what is this one likely to give us? That's what we want to find out. So since we know that this will 58.5 grams of sodium chloride will give us 44.8 gm cube of hydrochloric acid, then 5.68 is this 68? Sorry, 5.8 5.85 grams of sodium chloride will then give us 448 over 8.5 times 5.85 over 1. That will give us, let's see what we have here. That will give us 44.8 times 1.85 divided by 0.5. So our answer here is we have 4.48 dm cube, or we can also say 4.480 cm cube. 4480 cm cube. 4.48 dm cube, that is in dm cube. The other one is for dm cube, for cm cube. Thank you so much for coming this far, and if you have any question, you can also leave it as a comment. If you have not subscribed to our channel, we encourage you to subscribe in a way of supporting us and then encouraging us to do more, and also to enjoy our subsequent videos that will be posting. Now, thank you so much.